Hi guys, in today's video we will be rendering this nice moving triangle as you see on screen, and we will start with a project that we created last time where we just have this static triangle here on the screen, and we will go from here. So first of all we need to discuss how this animation is achieved. So you probably heard of phrase frames per second, in particular with regard to video games, where let's say you render 60 frames per second on screen, right? So what does that mean? Well, frame is essentially just a static image, and when you need to create some sort of animation like that with the triangle moving on the screen, what you do is each frame you render a different image where the object, in our case the triangle, has a slightly different position. And if you have enough frames, enough images, and you show them on screen relatively frequently, then the person who will be looking at the screen will have the impression that the object is moving. So that's exactly how the entire animation is done. And the higher the frame rate, the smoother everything this animation will feel. And so that's our goal for today. We need to convert our project where we just render one static triangle into a project that will be rendering 60 frames per second, and that way we will achieve the animation that we want. So let's get into it. So first of all, let's recap and see how project currently works. So in our view controller, at the moment when the view is first loaded, we create this renderer adapter and we call the draw method that simply delegates to our renderer in C++ and then displays the triangle on screen. And so that's not what we want. First of all, let's see how we can ensure that this draw method is being called not just once per application run, but 60 times per second, because that's what we want. So how do we get there? Well, Metal API provides us with special class called MTK delegate, and if we inherit our render adapter from that class, it will give us a method that will be automatically called 60 times per second, and that's actually exactly what we want. So let's start writing some code and we'll discuss it in more detail as we do it. So first of all, we want to inherit our render adapter from this MTK delegate, and we need to add some imports as well. So we did it, and then in the implementation, let's comment this out for now. And now that we inherited from that class, we can override the method called drawinMTKView. And this method will be called by Metal API 60 times per second. Well, we can adjust this number as we want, as we'll see later, but the default is 60 frames per second. So we will implement it just in a little bit, but first I wanted to go back to this view controller and add the required initialization here. So instead of just calling this draw method, we will call a constructor of this render adapter, and we will pass the view there so that we will have access to it inside render adapter. So let's do it. In fact, we can just use this. So first we allocate memory for that, and then we call constructor. Let's call it init with mtkview, and we pass our view. So we haven't created this method yet. So we will just stub in some code and we will connect everything together. Now we initiated, called the constructor of render adapter and passed view. And then the next thing that we need to do, we need to set a delegate. And our delegate will be render adapter. So by setting this delegate, we ensure that now view will ensure that this drawIn mtkview method that we overriding, it will be called 60 times per second. The next thing that we need to do is to implement this constructor in the renderer adapter. So, okay, we don't need this anymore. So let's do, we are currently declaring the constructor, and the name was init with mtkview, and we pass pointer to mtkview, and actually, yeah, like that. And so now we need to implement it. And the way we do it, so what we want to do here, we want to, in the same way we did before, create renderer, but in our case we don't need to pass drawable to renderer constructor. We just need to pass the device, and the reason we don't need to do it is because we will need to get a drawable each time we are rendering frame, because it will be different each time. And so in our case we will be passing drawable from view that we get as an input to drawIn mtkview method. So we don't need this in the constructor, and the constructor will just pass this thing, just a device. And of course, except for that, we also need to call the parent constructor. So basically we're just calling like a default constructor, and then we initializing prenderer, and then we need to return the instance of the class, of course, because this is a constructor. And then in this method, what we need to do, we need to call a draw method that will be called each frame. So essentially this method will be called each frame, and then we will simply delegate to renderer to do the actual work as we have been doing before. And so we, like we said, we will be passing current drawable, and of course we need to cast it to C++ as we did before. So that's what we did, and now it's time to move to C++ code and fix everything. First of all, our constructor arguments changed. We're no longer passing this. We no longer have draw method. Now we will have a draw frame with different arguments. So those will be metal drawable, pointer, both pointer and what it points to are constants because that's good enough for us. And yeah, we no longer need this field because we don't need to have it as a field on class because we will get this as an input to this method call. And then in the implementation we remove this, and let's for now just comment this out and implement draw frame. So for now let's just print something to console to ensure that our code is working at all. And so for that to work we also need to include IOStream. And so if everything works we should see multiple drawing frame strings in console. We expect to see 60 of them per second, obviously. So let's try to run it. Okay, build failed. We do this. It turns out I messed up Objective-C syntax. Of course, to call the method we need to write it like this. And so now it should all be good. Let's run the application. And yeah, that looks about right. We see those strings being printed in the console. So that's good. Let's talk a little bit more about how we achieved this functionality where Metal automatically calls this drawing MTK view 60 times per second. Essentially, it's a recommended way of doing things, creating a MTK view delegate and then implementing this method. But that's not the only way. That's not the only way. If you're interested, I am going to have a link in the description to documentation by Apple where they talk about different options to achieving same functionality, and this is the recommended way. So for those interested in how to change the default FPS, frames per second, you can set the preferred frames per second value to a number, and it should work as long as you have it below 60. And of course there are ways to achieve numbers above 60, and it's a advanced topic that is beyond the scope of this video. So the next thing is, let's copy all the contents that we had in the draw method previously. So let's just copy it, copy paste it. Okay, some refactoring here, and as we run it we got an error, which is expected. So turns out that in our MTK view delegate, which is this renderer adapter, there is one more method that has to be overridden, and we haven't done this, and therefore we get this problem. And this method is drawable size will change. So this method will be called every time we change the size of the essentially our window, because our entire window is our drawable, and so whenever we change the size of the window, that method will be called. And for our purposes, we don't need to do anything with it. We just need to override it. Yeah, drawable size will change. Here's this method, and we'll override it and leave it empty. But in a more complex applications, that will be required to do some work here, but we will not get into it in this video as well. So now that we did it, let's run it again, and right now we see our triangle. The difference with the last time we ran this project was that last time we only rendered it once. We rendered it once, and it was never changed since then. Our drawing only happened one time per application run. In this case, however, we are now rendering this triangle 60 times per second. And you, of course, it's not visible on screen because nothing is moving. There is no animation at all, but this image is being rendered 60 times per second. And so remember what we said in the beginning, that in order to achieve the animation, we just need to render different images, right? And so what we need to do, we need to slightly modify the triangle coordinates. Well, in our case, it is y coordinate because we want to move it up and down. And so we need to modify y coordinate every frame, right? And then in our vertex shader, we need to use the modified y coordinate to render it. And that should give us this animation effect. So let's see how we can do it. So first of all, by how much we change the y coordinate? Well, we can use some sort of variable that we will increment in every frame we render. With that, the value of that variable will be different every frame, and we can use that value to somehow modify the y coordinate. So let's see how we can do it. So let's say we have a float, let's call it timer, and then in the implementation we need to initialize it, and let's say in the draw frame method we will increment this value. So it was initialized to 0, and every frame we incremented value by 0.01. And then we can, on GPU, we can use the value of that timer every frame to modify the y coordinate. Let's see how we can do it. First of all, we need to pass it to GPU. We're going to pass it as a pointer to float from buffer 7, and then the body of this vertex. First of all, let's spread out our x, y, and z coordinates. X and z are not going to change, and the y coordinate is going to change. We will simply add whatever the value of scene function of timer to y coordinate. And the way it works is that sinus is this periodic, indefinite periodic function. Its value varies from -1 to 1 to -1 to 1 again. And since we adding this to our y coordinate is going to vary from y -1 to y +1, and the rate at which value will be changing depends on the value of our timer and by how much we increment it. To best understand it, we probably should do some debugging in our head just to understand what's going on. So when timer is 0, value of scene is going to be 0 as well. And for the next few frames, the values will be as follows. When timer is 0.01, value of scene function will be this, and value of y coordinate will be incremented by this value. Then next frame, when timer is 0.2, scene is this one and y is incremented by this one, and so on and so forth, until at some point value of scene will be up to 1, and then as soon as it hits 1, it will start decreasing with the same step all the way down to -1, and then it starts increasing back to 1 at this step, and that way our value of y coordinate is going to change smoothly from y -1 to y +1, and so on and so forth. And what's important is that the fact that we picked timer increment as this low of a value, it ensures that our triangle is moving smoothly. So it's moving slowly, fairly slowly. And if you want it to move faster, then we need to increase this timer value. We make it greater, then triangle will start moving faster. So the only thing that is left for us to do is to write code on CPU so that this value is actually, this timer is actually passed to GPU. So far we only been incrementing timer, and in the same way we did when we were passing vertices, we can pass this timer variable, and we can use a different method to do it. So we just passing a pointer to that variable, pointer to a float. The length of that would be just a size of float, and index, as we said, buffer index, that's 7, right? Because we said we want to use that here. And so this set vertex bytes, it's a lightweight alternative to vertex buffer. The difference is that we don't need to create a buffer to pass something using vertex bytes. We can simply pass a pointer to a data structure or to just a built-in type like float. And Apple recommends using this method only when the data that you're passing is less than 4 kilobytes. So if it's less than 4 kilobytes, you can use this lightweight approach to pass it to GPU. Otherwise, it is recommended to use a vertex buffer. Alright, so that should be all that we needed to do. Let's try to run this. And we get our triangle moving. So hopefully you enjoyed this video. Let me know what you think in the comments below. Please like this video, subscribe to my channel for more videos on metal APIs. Thank you guys, and I'll see you soon.